On this episode of the podcast, I have with me Phillip Schafer. He is the director of data science at IronNet cybersecurity. We got a couple interesting topics we're going to dive into today. We're going to talk about Phillip's path from academia to industry, the challenges and nuances he sees within the cybersecurity industry, and we're going to touch on his transition to a director role. Phillip, thanks for being on the podcast.
Thanks, Amir. It's great to be here. Thanks for having me.
Absolutely. So I know we got a few things to cover, but before we do, to kind of set the stage, maybe a little intro about yourself, who you are, how you got here, and set the stage for the rest of our conversation.
Sure. So as you mentioned, I am the newly minted director of data science at IronNet. IronNet is a cybersecurity company that is generally based out of the DC, Virginia, Maryland area, although we're increasingly having a global footprint. And actually, with the pandemic situation currently, we're moved permanently to a 100% virtual workforce. But in any case, I guess you'd call it a late stage startup. We've been around for about 5 years. And the company was founded by General Keith Alexander, who is kind of a big name in the cybersecurity community. He's the former director of the NSA, the first commander of U.S. Cyber Command, and has really done a lot to defend the U.S. and its allies in cyberspace. So our company is kind of continuing that mission and bringing some of those same ideas and technologies over to the private sector. So that's where I am right now. It's a completely it was for me when I started at IronNet, a completely new field of application for my skills as a data scientist. I guess I can go through a little bit of my background. I had a background in physics. And so I did my PhD at Penn State, finished up in 2015. And my path through academia was generally focused on computation. I got to start as an undergrad doing modeling and simulation for actually in the geology department, doing modeling convection inside the Earth. And, after a year spent teaching high school, I had gone back to the Yale geology department and was studying precipitation, doing an orographic precipitation study. So that was my first kind of experience munging data together from, weather radar data and balloon soundings and rain gauge data and all of that sort of thing, and doing data visualizations and that kind of fun stuff. And I went to grad school thinking I was going to finally be a real experimental physicist. I thought that, real physicists do experiments. And I worked for a couple of years actually in an atomic physics lab and realized that I just really liked doing the computational work a lot better. So I switched gears and I went into kind of a multidisciplinary area working with neuroscientists at Penn State's Center for Neural Engineering, who are studying how the brain processes speech signals. And so I worked on developing algorithms for speech recognition that were generally based off of some of those ideas coming out of the neuroscience community. Through all of this, I never thought of myself as a data scientist and really wasn't aware of what that meant particularly. But as I was finishing up the PhD, email circulated around the physics department talking about this program called the Data Incubator, which is kind of a boot camp for people with PhD backgrounds who wanted to make their way into data science and industry. And I thought, sure, I'll give that a shot. And actually ended up just really loving it, even from the first, problems that they sent out as part of the application. I was like, wow, this is so much fun solving these kind of data-driven problems. It was sort of linked to some of the techniques and things that I had used in grad school, but in just a completely different subject area. So really enjoyed that program. And by way of the Data Incubator, made my way to Optoro, which is a startup in DC that works with retail returns. Not an area that I ever would have imagined myself working in as a physicist, but again, it was just a really fun place to apply some of those skills that I built in grad school and to make kind of a direct impact on building that data science program and helping out the company to meet some of those goals. So and then from there I made my way to IronNet. Again, it was a big switch going into cybersecurity, and I'm still a student of cybersecurity, surrounded with a lot of people with perhaps deeper expertise than me, definitely deeper in many cases. But it's been a lot of fun kind of, again, applying some of those same problem-solving skills that I've brought through my entire career through academia and beyond to this new area.
Yeah, it's, fantastic journey, and congrats on becoming a new director of data science there. And I guess maybe, since it's the last thing you mentioned, maybe we'll dive into this area. You previously worked at a company that did something fantastically different than security. What are some of maybe the nuances, the challenges now that you are working in the security field that you see from the data science perspective that you hadn't anticipated with your previous experience and roles?
One of the most obvious differences is just the scale of data that we're working with. So IronNet is in the network detection and response realm of cybersecurity. So what that means is that we pull in just massive amounts of data from one of our customer networks, and we have to analyze that data and detect bad people doing bad things. And so, whereas a lot of the techniques and ways of doing analysis carry through directly, just the idea of having to scale up your algorithms to work on those large volumes of data is kind of a different approach. Aside from that, there are some unique challenges for cybersecurity. One is that inherently we're looking for very rare events. You're looking for the needle in the haystack. Whereas, in other machine learning or data science applications, it becomes much more easy to kind of look at the results of your models running in production and say, oh yeah, I found these things. Those things look like the right ones. Everything seems to be good. In cybersecurity, it can be hard to tell, well, am I not finding anything because there's nothing going on? Or am I not finding something because my algorithm is not working correctly? So kind of in more technical terms, finding large enough labeled data sets of the kinds of activity that you're trying to detect is a real challenge. And so part of the way that we are tackling that problem at IronNet is we have a team of cybersecurity researchers whose job it is to do that data collection and to kind of narrow down the types of activity that we're trying to find with our algorithms. But it remains a big challenge. And so, yeah, it does kind of call for, in some cases, a different set of data science techniques.
Just curious, when you're talking about large volume of data, what are we talking about?
Well, it varies on the size of the network. So often, if we put in a sensor, it's a gigabit sensor or a 10 gigabit sensor. So that's gigabits per second of data that we're collecting. And we're actually storing off all of that data as packet capture. So just the raw network data goes into the database. And then we're also extracting metadata from that, which is kind of source and destination. What ports was it going on? What was the protocol? We're doing some kind of protocol parsing to understand more of like what's in HTTP headers, TLS headers, and some of the other kind of metadata that you can find in there. And so, pretty much right away, we start the process of trying to narrow that down from the raw PCAP to metadata that we can, store in HDFS and then run analytics over. We're using Spark as the platform. And then you're finding a smaller set of detections out of that we're calling detection events. And then we're running more analytics at that stage to try to narrow things down. And so it's a whole stack of technologies that go into kind of trying to reduce that volume of data down to a workable size.
I guess just I mentioned that I spoke to somebody about machine learning within email security, and an interesting discussion point was how hackers and creators of malware are aware of the ML models and techniques that software platforms are trying to use. In your case, network detection. Are you guys seeing a similar challenge where the people trying to get in, are trying to understand how you're trying to block them, and there's this elaborate chess match of trying to detect what that is?
It is definitely a cat and mouse game for sure. You look at the early stages of these cyber defense techniques where it was largely based on signatures, right? So someone downloads a file, you take a hash of the file, you look for an exact match of that hash on some database of known malware. And yeah, people really quickly realize that that's very easy to get around, right? Because if you change a couple bits in your file, you don't have the same hash anymore and you've evaded detection. So a lot of what we're trying to do at IronNet is look for, instead of those kind of signatures, we're looking for more generic behaviors that indicate sort of like we call it the tactics, techniques, and procedures that are used by attackers that are really held in common, regardless of the specific malware that people are using. Yeah, so we talk about this idea of the cyber kill chain, all the different stages of an attack. Early on, you're doing reconnaissance, you're scanning over ports and IPs in the network if you can, trying to understand what entities are there, what services they're running, what the vulnerabilities might be. You're moving from there, you're like, we call it the access stage. You're trying to get a foothold. You may be moving laterally through the network. So you've found your way in. You're trying to find, resources that you want to, potentially compromise. There's we have analytics targeted at C2 activity, which is the idea of malware, once it's implanted, needs to communicate outwards with a command and control server. That's what C2 means, command and control, outside the network that's controlled by the hacker. So there's a set of behaviors that are associated with that. For example, periodic beaconing is one. Sometimes the malware will just call out every 5 minutes, every hour, whatever the case may be, and look for instructions from the hacker. The later stages of the kill chain, the action, what are you actually trying to do? You're trying to maybe exfiltrate data out of the network so we can catch you at that stage. And so, within each of those broad categories of behavior, there's a lot of different techniques that hackers can use, but we're trying to tune our analytics to sort of catch that broad class of behavior so that even if a signature wouldn't necessarily catch it, you can evade detection. When the aperture is too narrow, like for a signature, then it's more easy to evade, but we're trying to catch kind of these broader classes of behavior. For some of those more machine learning based approaches to problems, there are vulnerabilities associated there, but it's kind of a constant cat and mouse game of trying to get around the measures that attackers put in place.
Awesome. And I guess you mentioned, one of the challenges is labeling the data. What are you seeing, I guess, from that perspective? And what do you guys have to do to bridge that gap? Obviously, you've got a ton of network data you're capturing.
Yeah. So, part of what we do is we're trying to leverage the activities of our cyber operations center, the SIOC. And so a lot of times what's happening is, we create the analytics. They say there's some behavior such as periodic beaconing that we're trying to find this particular behavior. And we sort of narrowed it down to a small set of things that can be looked at by humans. And then we send those over to the SIOC, and they're going to look through those and do kind of more detailed triage and investigation to label those events as either being malicious or benign, or sometimes suspicious if it's not quite a smoking gun enough to call it malicious activity. And we can take that as feedback that goes back into training the algorithm. So it's this kind of circular process of we come up with initial results, we have kind of a human in the loop labeling those events, and then we're feeding that back in and improving our methods for detecting those the next time around. That all said, there are still significant challenges. Increasingly in cybersecurity, a lot of the network traffic that we see is encrypted. And so it becomes very hard for people in the SIOC to triage that and to say definitively whether this was malicious or benign. Often we have to settle for not was this actually malicious or benign, but just was it representative of the kind of behavior that we were trying to find, right? So was it C2 behavior? Was it data exfiltration? Was it lateral movement? And then what we have to kind of do to put those pieces together is then link together multiple data points, right? So we say, all right, we saw this beaconing behavior. We're not really sure if it's malware, but we can put that together with some other detections we found elsewhere in the kill chain and tell a better story about what's happening in the data overall. So there is a lot of back and forth between the algorithmic development and the kind of manual triage processes used by our SOC. And we're intending these tools to be used not only by our analysts, but also analysts in the customer SOC. We want to give them the best insights and kind of boiled down data that they can use and have at their fingertips to investigate things and then respond as appropriate.
Interesting. It sounds like it's a definitely unique challenge having to deal with encrypted data and the models you guys are building. I guess to touch on one aspect, I know you mentioned a new role as a director at IronNet. With that comes with different responsibilities. What's shifted in your world in the last month? Like, what are you seeing? You're a senior data scientist, several years experience. Now you moved into a role where you're responsible, obviously, for a lot more. And obviously the context of some of the complexities of security. What is your relationship in terms of, also with the business, in terms of, would you participate and kind of bring to the table now that you're the director?
In some ways, it's been a soft transition for me. I have sort of been taking increasingly a leadership role in the team over the last several months. I'm never content to just sort of sit down and work on the problem that I've been assigned and try to just heads down, do my machine learning or whatever. I'm always asking the questions of like, why am I doing this? Like, what is the bigger problem that we're trying to solve? How am I going to know that this is actually providing value? And so, I see my move into a management role as kind of an extension of that. I think a lot of times for data science, what we want is we want to make sure that our efforts as researchers are adding up to some kind of product value, that we are solving the right problems, and that we have metrics for success. And so that's a lot of what I'm trying to bring to our team is closing the loop on some of the feedback that we're getting from analysts on the results of our algorithms, and trying to understand better in collaboration with our cybersecurity experts where the gaps are in our detection coverage and where we can have better results through application of various data science and machine learning techniques, kind of defining the problems that we work on and make sure that everyone's set up to have success and to have kind of concrete contributions out of their work.
Do you see, I guess, a question I've been asking a lot of data scientists, and I guess within the context of IronNet, it's a different product, different space. How involved do you get, with the product people, with business strategy? Is that something that's part of your day to day, or maybe that's still to come?
It is part of the day to day. And I think that's kind of inherent to working at a startup. I mean, I saw this similarly at Optoro, where there's just so many open questions about exactly which way the product should go. There's 1,000 different things you could be working on at any given time. And particularly at IronNet, in the field that we're in, it takes a lot of different heads coming together to make some of those decisions. Our team has some great data scientists, people with backgrounds like mine, PhDs, and kind of the math science and that kind of background. But we don't really have the cybersecurity expertise necessarily be able to define our own problems, to decide what to work on completely on our own. So we need to collaborate with them. We need to collaborate with product to understand what the gaps in the market are and what the customers are seeking. And so, yeah, there is a lot of discussion and a lot of kind of back and forth to define what we should be working on and how to make it all add up.
Interesting. I guess you do have a PhD. You made your way into the workplace. Just to kind of touch on that, like I know I speak to a lot of people in PhD programs, and the concept of leaving academia always seems to be a challenge. Like, how am I going to make that happen? Yeah, am I being provided enough support to not go down the teaching path and actually go work? What was your experience like?
Well, my experience was I didn't think too much about what was coming next through most of the PhD, and I think that I think that's the
Just get
case with
through
a
it at
lot
that
of
point.
people. Yeah, but no, it is an important question that I think that I probably should have asked myself more, and that others probably should as well. I remember we had like a kind of orientation class the first year of the PhD program where we were learning about academia and how research works and career paths and that sort of thing. And the question was asked, like, what does everyone here think that you're going to do with your career? And like universally, everyone said they're going to be an academic, right? Which is just impossible. That this is like, if being an academic means you're going to be a professor, there aren't that many professor jobs to support all of the PhDs who are coming through, all the physics programs in the world. So the reality is that, yeah, you will have to find another way once you're done with grad school, most likely. A few people do have success on the academic route. And there are some things that you can do to set yourself up well to make the transition. I think I was lucky in that a lot of the work that I did in my dissertation built skills that were directly applicable to data science and to the next stages of my career. And certainly the data incubator, the bootcamp program, helped kind of tune those skills in a kind of more finely to help me have success in job interviews. But yeah, I think that if people just had a more realistic view of what the possibilities were, at least of what comes next, that they could make better decisions. A couple of things that come to mind there, I've spent most of my PhD working in MATLAB, which is kind of the standard tool for the field that I was in. And looking back now, I would much rather have done most of that work in Python. I knew Python at the time, but it's just I was kind of locked into that. But if I had pushed harder, could I have worked in Python? Maybe so. And yeah, I kind of wish that I had. Also thinking about version control, I can't imagine now writing software, writing code without checking things into Git and using GitHub and that whole workflow. But somehow managed, 7 years of the PhD without ever doing that. And so, yeah, if just having some awareness of what some of the skills are that are in demand, both in terms of coding languages and also, if data science is the goal, what kind of techniques in terms of machine learning and statistics and so forth are required, and just making sure that you're working towards building those skill sets through the time of PhD.
Absolutely. And you're looking at that, obviously MATLAB is a gold standard, in dealing probably with physics, math. The Python side, going through the boot camp, is that the gap that you're trying to address? Because I know obviously you touched on being in a boot camp.
Yeah. So the data incubator is interesting because it's a whole kind of cohort of people who are coming out of PhD programs, and sort of it's people from a lot of different fields, but generally coming in with that academic mindset. I think that the gaps that people have, vary. For me, certainly, like I was very well familiar with statistics and machine learning and some of those concepts, but it was just for me kind of a crash course in learning how to do everything that I knew how to do in MATLAB and Python using NumPy and SciPy and pandas and scikit-learn and that whole Python data stack. Yeah, so if you come in with a kind of baseline of knowledge like that, I think it does help. And it's certainly the data incubator is set up that way. It's a lot of material in a very short amount of time with the idea that you've already got 90% of it and you just need to fill in the gaps to be a really competitive job candidate.
Makes sense. And I guess from that standpoint, now that you've gotten further into your career outside of the Python side, the technical side, does the PhD help? And I've gotten different perspectives. When you're coming into the first job, you're obviously prepared to solve problems a certain way. Does it help I guess in terms of real world problem solving, or did you have to relearn how to potentially solve business problems versus academic problems?
I really think that a lot of the problem solving approach that I learned in academia is directly applicable. You think about what distinguishes data science from, say, engineering, which is, engineering, it's a little more well-defined. You're given a set of requirements. You're going to, figure out how to structure your code to meet those requirements, pass the tests, move on to the next thing. Data science, it is kind of by nature more open-ended. And especially in a big business environment or at a startup, you're going to be handed problems that the person handing them to you is not very quantitative in some cases. Or, it's just the nature of how you come up with new ideas is that often they're kind of vaguely defined. And you have to figure out, how do I translate that vision into actual steps to get me from point A to point B, which I think is very similar to what you have in research. When you're in your PhD program, no one can map out the exact steps that will take you from here to publishing your paper or, writing your dissertation. You have to work your way through it with trial and error, try something, understand why it worked or didn't work, kind of redirect yourself. And I think a lot of that does apply very directly to data science at businesses as well. I think the real shift in mindset, it really comes down to the timeframes, right? Whereas in academia, you can work for a year or several years on a problem. You look at a PhD, even a longer period of time, and you're really trying to get down to the root of things and understand everything at a very granular level. And you have the time to wait and not wait, but continue working over a long period to do that. If it takes you a year to do something at a startup, then the company's already moved on, right? You just have to have a much faster cycle of kind of have an idea, try it out, make a prototype, see if it has value, measure that value. And you have to be comfortable with the idea that after a few months of working on something, you've only gotten 80% of the way there. You haven't really maybe completely solved the problem, but it may be good enough. And based on, the business needs at that time, you need to move on to something else. So I think some academics struggle with that shift in mindset. Personally, I found it kind of liberating in the sense that you just see the results of your work so much more quickly. You work on something for a few months, you get your model in production, you start to see the results coming in, you can analyze those results and see I made the business X amount of dollars with that work that I did. And it's just a much quicker feedback cycle to see the kind of value that you're providing. So I find it to be a really great transition.
Awesome. I guess, now looking back, your current role, different industries. I think when it comes to, let's say, a retail or an e-commerce, I think, a data scientist will have a different feedback loop and there's a lot of learnings that they can leverage. Going into something like security where it's just a different type of environment, is there anything you wish you would have picked up specific to what you do now?
Well, any field that you go into, bevy of new things that you have to learn. And thinking about when I went into my project in grad school, I didn't know anything about neuroscience. And so I had to take neuroscience classes and understand just some biology and stuff that I just never had touched on before. And so it's no different at Optoro and the retail industry, just learning some of the jargon and concepts that are in play there. The same with cybersecurity. So, my first couple months in the job, I, bought a stack of textbooks and was learning about networking and network protocols and just learning some of the basics of the field. And, that's another area where I think having an academic background, it kind of sets you up pretty well. You know how to dive into something and be a self-learner. And so yeah, certainly I wouldn't call myself a cybersecurity expert at this point, but I certainly know a lot more than I did a couple of years ago. And I find that's kind of part of the fun of the job is just always learning and always taking on new things and jumping into new fields.
Yeah, I'd imagine you enjoy learning, and that's definitely got to be a big positive. I think a lot of people, when they go into a new job, the first thought is, how am I going to tackle that? Where am I going to start? In your case, pop a couple textbooks and ramp up is second nature, which has got to be a great thing.
Mhm.
Awesome. Yeah, in terms of, I guess, I was going to ask you, a final question in terms of maybe the transition to the director role. Obviously, you've been ramping up along the way. You weren't just diving straight in. How are you handling, I guess, the actual, working with people in terms of the management of people? Like, that's a whole different skill set that, is a little bit different than learning in a textbook.
I don't know. You have to ask some of my team members how I'm handling that. But I've always been someone I like to work collaboratively, and I'm kind of nosy in the way of I like to understand what other people are working on and sort of offer my advice, whether I solicit it or not. You should try this way of modeling things or that way. So certainly from a technical leadership perspective, it's just I set up kind of more frequent check-ins with people to go over what they're working on and offer ideas and just have a back and forth and that sort of thing. Yeah, and in terms of leading people from a more managerial perspective, like I said, I do see it more as a problem of trying to set people up for success. Certainly thinking back on managers that I've enjoyed working for in the past, they always put their team first. They just sort of lay the groundwork for you to be able to come in at your performance review at the end of the quarter or the year, whatever the case may be, and have a list of accomplishments to point to and say, I brought some value to the company. And so that's kind of how I view my role as manager. And, I'm still early on in this, but yeah, I'm hoping that that's what I can provide to the team.
Absolutely. Oh, awesome. It sounds like you've definitely had an interesting journey, pretty challenging, and you're kind of set up to kind of tackle the next chapter. So I definitely appreciate you being on and talking about your path. I think it's really interesting.
Thanks for having me. It was fun talking to you. Yeah, I hope that some of your listeners can see some of their story in mine, and I can help guide some of them through that transition into the data science as well.
So if somebody does have a question, a follow up, is LinkedIn the best avenue to get a hold of you? Twitter? What would be the best social handle?
Sure, LinkedIn is a good way. Yep.
Okay, cool. So we'll include that in the show notes. Again, thank you for being on. It was a pleasure to talk to you. And then we will be back again next week, new guest. In the meantime, definitely like to hear any questions that you might have or topics that you want us to cover. Always looking for some new ideas. Leave us a review, Apple, Google, Spotify, you name it. It helps us get the podcast out to more people. Until next week, thanks.